In today's video, we're going to be looking at the different categories of waves. Now, we've been talking about the classic representation of a wave that looks just like you have this up and down thing, kind of like a snake shaking, slithering. We did this with the lab, with the slinkies, where you just were moving it side to side so that the wave could be produced like that. Well, this type of a wave is actually known as a transverse wave. Transverse waves are where the medium is displaced perpendicular to the direction of the energy. So if we're talking about the energy moving in that direction, then the wave causes the medium to go up and down like that, just the way we saw it in the slinky pattern. So it's going up like this and down and up and down, kind of like when people do their little fancy wave with their arms, you know, in dancing. Anyway, it's a perpendicular to the medium. As it's traveling, the medium goes up and down and the energy is going through. That's the first type of wave. The second wave is longitudinal waves. Longitudinal waves is where the medium moves in the same direction or parallel to the direction that the wave is moving. Now, I tried to draw a little representation of this. So if the energy is moving from side to side here, what happens is that the particles themselves will start squeezing together. As they come together, they transfer their energy from one particle to the other, and then they start relaxing and separating as the energy goes through, and then it hits another little section that causes them to come together, and then again, as the energy goes through, it relaxes. Now, with these type of waves, instead of saying crest and trough the way we do here, because we don't have that high and that low, what we call it is a compression, where the particles are squeezed together, and then we have the refraction where they start to relax. And the compression here is really what we look at to measure the amplitude of the wave. The amplitude is measuring, again, the amount of energy, and we look at how dense or close together the particles are, how squeezed together these are, and then they relax until as the energy goes through it, then they relax and then they come together and relax. Now with the slinkies, some of you actually were doing that. Somebody was holding a slinky on one side and another person was holding it on this side, and you push the slinky towards that person, and you could see how the ripple went through and it came back, and we saw that movement of longitudinal waves. Now our third category where we can put different wave types is the surface waves. Surface waves are where the particles of the medium undergo this circular motion, and I tried representing it like, say, a piece of wood. As the wave travels around like this, and it goes around and around, the wood is going around in a circular motion until it ends up back at the surface all the way up. Now usually we see this only at the surface of the actual medium, not throughout the whole thing. This is moving all the medium up or down. This is moving all the medium. It's squeezing and relaxing, squeezing and relaxing. On this type of wave, the only place you really see displacement is at the very top. At the bottom, underneath the surface, that's why they're called surface waves, at the bottom of the surface, the medium is both traveling transversely and longitudinally. So we have all three motions going on really here at surface waves, but we only really see the movement at the very top. Now, as we go through the different categories of waves, we also have to describe two other ways of classifying our waves, not just as how the medium moves up and down, side to side, or in circular motion. We also have a distinction between what we call mechanical waves and electromagnetic waves, and that's the next section that we're going to look at.